हाँ तुषार, चालू कीजिए।
हाँ,
तुषार। हाँ।
थैंक यू सर। हाँ, uh, good afternoon to all of you, and welcome to the second session of this today's second session. I'm going to introduce today's uh, lecturer, Dr. Jitendra Singh Chandok. Sir has more than 30 years of experience working in various functions like international business, renewable energy, including floating solar forecasting, hybrid RE systems with battery energy storage system, and application of artificial intelligence for energy sector. He has published many papers on hybrid renewable system integration, AI applications for thermal and international journals in the era of energy sector. He has patent of floaters, robotic systems for solar panel cleaning and battery storage. Presently, Sir is working as general manager and head of international business of NTPC, looking after the project management consultancy of 6,500 MW solar park in association with ISA, investment opportunities in Sri Lanka, Bangladesh, and other countries, and O&M service support to various countries. Before joining the international business, Sir was the head of the project of India's largest solar park of 4,750 megawatt and 350 megawatt wind in Bhuj, Gujarat. Sir has done masters in power generation technology from IIT Delhi with the focus on the use of artificial intelligence for plant advisory and control. PhD from IIT Delhi on hybrid renewable systems with flexible grid integration. So such a eminent personality among the us. I welcome sir and thank you once again to the MM-TTC Center, Rani Durgavati Vishwavidyalaya. Thank you sir. Over to Sanjeev Pandey sir. Thank you sir.
Chandok sir, please start. Over to you.
Very good morning, sir. And definitely it is my pleasure as well as I am very thankful to the organizing committee that I have been invited for this the lecture. In fact, I am basically belongs to a power generating company which is a Maharatna of NTPC, a Maharatna of country that is NTPC Limited. And you may be knowing that this company is basically a pioneer in setting up of records from the last 50 years. In fact, in any field, including the thermal power, but right now more focusing on the renewable power, we have 76,000 megawatt of capacity, solar as well as thermal. And out of which we are already reached the 9,000 megawatt from the solar and wind and storage. Parallel to that, our focus is that in next 5 to 6 years, by 2030, we have to include 50 gigawatt more, 50,000 megawatt more through the renewable energy. So this is basically kind of potential and kind of basically technologies as well as capacity additions NTPC is planning to do. And based on that thing, basically, I just wanted to introduce what exactly the solar systems are and how we are able to use it. Because always, apart from the academic, the industrial perspective is very, very important. And when we talk about the industrial perspective, it not only covers basically the academic understanding, but at the same time, what actually the manufacturing sector is facing, what exactly the system and erection commissioning stage is facing, and how the things are moving according to that. So with that, I just wanted to open my presentation and I'll take you to the detail of those things. 1 minute, please. Um, Is my share screen visible?
जी हाँ बिल्कुल सर। फर्स्ट स्लाइड।
जी सर, हो रहा है।
I'm not.
Sir, you can go to slideshow.
That's why actually I am just.
इफ एनी प्रॉब्लम सर, पांडे सर अपन शेयर कर सकते हैं क्या पीपीटी लेके?
कर सकते हैं सर, कर सकते हैं।
Hope the presentation is visible. Sorry for the delay.
नो प्रॉब्लम, इट इज विजिबल, इट इज विजिबल, नो प्रॉब्लम।
Okay. Thank you so much. So as I was telling you, sir, that there are a lot of things which NTPC is already doing, and based on those things, I have captured some of the areas which we are already doing with respect to the renewable energy. And solar photovoltaic system is one such technology which is very, very important and which is very, very useful for the country like India. Be it a central solar plant or be a rooftop solar plant, or be it nowadays we are talking about the floating solar plant also, where the solar plant is basically captured on the water bodies. So I just wanted to cover the entire discussions as well as this lecture into the 4-5 areas where I would like to take you with respect to what exactly the solar energy is. And when we talk about solar energy, we need to understand the solar PV systems, what technology advancement which are happening in the solar energy systems, then what the design aspect as well as the economics of the solar plant. And there are several applications and there are several understanding which we need to build, that how this solar plant and solar panels are getting degraded over a period of time. Because when we talk of any system, we need to understand that it is very important to have a sustenance of that particular plant. Otherwise, what will happen, that plant will degrade very fast and we need to go for a new plant in that sense. So that's why it is very important to have understanding of many aspects. So going into the basics as well as understanding upon the various aspects, we know that India is a country where we have huge number of basically resources of solar radiations available. If only we consider the Rajasthan and Gujarat part only, then we will be in a position to get a huge number of resources which can be available from this particular plant. And as far as the India is concerned, we are having a very good solar radiation in the sense that almost 4 to 7 kilowatt hour per meter square per day kind of a radiation is available. Another very important aspect is that almost out of 365 days, 250 to 300 sunny days we are already having. And at the same time, we have a very efficient systems which can take this thing into the consideration. So, as far as the solar index part is concerned, when we talk of solar index, it means that it is basically the kind of radiation which is available, the kind of infrastructure which is available, and at the same time, when this radiation is available, it is available in the sense to make useful. So that way, we are also having a very good solar index, and we come as a second number after US. And this is very important aspect to understand. Now, when we talk of the solar energy is basically, you can say, according to the Planck's constant or Planck's theory, the spectrum of solar is very similar to when basically a black body radiation emits at 5760 Kelvin black body. And that spectrum is very similar. What is basically the sun spectrum is that. As you can see that the sun spectrum is basically having a three component, a big component. It basically falls in ultraviolet as well as in visible as well as in infrared. The major portion is basically the visible and infrared. But since we are basically dealing with solar photovoltaic, that's why we are mostly dealing with the visible spectrum, which consists of almost 47% of the solar energy. And definitely the infrared also comes into picture, where basically the 46% of the energy will come as a heat in the form of infrared. So when we talk of semiconductors, basically which are the core heart of the solar plant, then semiconductor basically works in the area of visible spectrum. And that visible spectrum is almost around 47% of solar energy. But there are research going on, and at the same time, there are plants available where people are able to make a kind of a solar cell where they are able to capture all the three spectrums of the solar energy by means of different chemistries, by means of different components, by sandwiching the different components. We are able to capture the ultraviolet, we are able to capture the visible, we are able to capture the infrared. And by that way, it is sometimes the efficiency has gone up to 50% also for the case of solar cell when it is being used for the solar this concentrated solar application. So now, when we are talking of the normal solar plant, we generally talk of the visible spectrum only. But there are some exceptions where we are able to capture all the three part of the spectrum. Most important aspect of how to understand the basically the terminology of the radiation. So when we talk of the terminology, we talk of the irradiance, we talk of the insolation, and we talk of the solar constant. So these three important aspects is that a kind of solar energy falling on a per unit area meter square is basically the called the irradiance. So when we talk of that 900 watt per meter square is basically the solar energy is basically falling. It is basically a 1 meter square area where this 900 watt is falling, and that is called the irradiance. Likewise, when we talk of insolation, it is not the power, it is basically the energy. So that's why it includes the time period as well. So when we talk of insolation, it is watt hour per meter square. Definitely, the cumulative energy over a period of 1 hour, say for example, by this 900 watt, which just I talked about regarding the irradiance, that is basically the insolation. So insolation is the terminology used for the energy, and the radius is the terminology used for the power for the solar. And then important for terminology comes up with the solar constant. So as you understand that when the power is emitted from the sun, it is almost 4.96 into 10 to the power 7 watt per meter square kind of a power which is basically emitting from the sun. But when it reaches to the atmosphere, just above the atmosphere, it is almost 1367 watt per meter square, and that is going to be basically coming into the earth. From the atmosphere it is coming to the earth. So that 1367 watt per meter square is called the solar constant, and that is having a very important concept which basically we wanted to show you in the next screen also. Apart from that, there are three more important terminology which are needs to be understood, that what is basically the direct normal irradiance, what is the diffuse horizontal irradiance, and what is the global horizontal irradiance. Now, when we talk of the direct normal irradiance, it means that when a surface is basically facing the sunlight, parallel means perpendicular to the sunlight. So whenever we are having a system like any system which is facing sunlight perpendicularly, then there will be a kind of a direct normal irradiance, which is very useful. Because when the sunlight comes to the earth, this consists of three components. One is basically the direct, one is basically the diffuse, and other one is the global. So, because of the various dust particle, because of the various things available in the sky, normally the sunlight gets diffused as well. So, when we talk of direct normal irradiance, then it is basically the only the normal component which is basically used. So, when we talk of any kind of a system where we are using the concentrator, like you have the mirror, then the sunlight is falling on the mirror, and from the mirror it is basically getting concentrated on some surface, some radiate, some kind of a surface it is getting concentrated. Then definitely concentration can always only be possible, or the focus can only be possible when the rays are falling perpendicular to the that mirror or that lens kind of thing. So that's why at that point of time, for those applications, we generally use the direct normal irradiance. Like in case of solar thermal systems, solar thermal में क्या है basically कि when we are talking of solar thermal system, we are having a mirror. The sunlight is falling on the mirror, and from that mirror, it is focusing on a area which is called the receiver, and that receiver is carrying the basically the water, and water get converted into the steam. So this is kind of a concept which is used in the solar thermal. There, when we talk of any kind of a radiation, then it is purely a DNI, direct normal irradiance. So this is the concept of direct normal irradiance. Likewise, diffuse horizontal irradiance. So similarly, when the surface is placed horizontally, and whatever diffuse light which is coming on that surface is basically called the diffuse horizontal irradiance. But the most important is basically the global horizontal irradiance, which is very useful for the solar plant of the photovoltaic. When we talk of photovoltaic plant of like solar module, आप जब बात करते हैं, so that solar module is getting the sunlight from everywhere. It is having a direct also, it is having a diffuse also. The beauty of solar panel is that from the direct or from the diffuse, whatever sunlight is coming up, it is able to convert that power in that particular energy into the solar energy. And that is basically the GHI, we call it. That is the global horizontal irradiance. तो जब भी हम सोलर पीवी की बात करते हैं तो हम हमेशा जीएचआई की बात करते हैं, दैट इज द ग्लोबल हॉरिजॉन्टल इरेडियंस व्हिच इज यूज्ड फॉर सोलर पीवी, सोलर फोटोवोल्टाइक। और जब भी हम सोलर थर्मल की बात करते हैं तो जनरली हम डीएनआई की बात करते हैं, वेयर बेसिकली वी आर गेटिंग द सोलर पावर परपेंडिकुलर टू द सरफेस, so that it can focus on any receiver or any particular point where it can be converted further into a other form of energy, like water is going to convert it into the steam, and then steam is basically used for the turbine to move, and then for turbine to generator, it will generate the power. So that is a different ball game. And the PV is directly conversion from the solar energy to the electrical energy. Another important aspect of solar radiation terminology is basically the path length or air mass ratio. हमें सबको ही पता है basically कि there are lot of dust particle or the diffuse particle in the sky, the atmosphere. And normally when it comes from the when the sunlight comes from the entering into the atmosphere, it passes through various kind of a scattering. And because of that, there should be some kind of understanding, standard test condition we need to build. And there we find one air mass ratio is very important. The air mass ratio is that whatever basically is coming the radiation, it will come to normal ground in a reduced manner. So generally the standard air mass ratio is 1.5, which means that जैसे ये टेबल में दिखाया हमने कि जब हम AM0 की बात करते हैं, that means the sunlight is not entered into the normal atmosphere. It is very clean atmosphere. It is the power is basically 1.37 kilowatt per meter square. But when it reaches to Earth, it will reduce from 1.37 to 1, and that is called the AM 1.5. So air mass ratio 1.5 is basically defined as 1 kilowatt per meter square or 1000 watt per meter square, whereas AM0 is defined as 1370 watt per meter square. Or whenever we are going for any test conditions for the solar energy, then we call it the standard test condition for any solar power, a solar plant or solar panel is that we need to measure the panel wattage at the three conditions. One is that the radiation is falling through the air mass ratio of 1.5. Second, the radiation is basically the 1000 watt per meter square. And third is the temperature is 25 degrees centigrade. So with these three numbers, we generally define that the panel, which is the module, is basically having a wattage, which is, say, for example, 500 watt or 490 watt peak. And this is called the peak also. Every time when you see the module will be always comes with the 500 watt peak or 350 watt peak. So this peak defines these three conditions. So when we call it 500 watt peak, it means that the 500 watt, the module will be able to produce when the radiation is falling at AM 1.5, when the radiation is basically 1000 watt per meter square, and when the temperature, the ambient temperature is basically the 25 degrees centigrade at that point of time. So in general, if we define from AM0 to AM1.5, that 1.36 is basically the falling as coming to the Earth. And when it reaches to the Earth, it is almost 1 kilowatt per meter square, which is basically the AM1.5, which just I explained. You can see the typical solar irradiance in a case where basically software is being used. There are several software which are available. One is solar GIS software, one is basically the metronome software. Several softwares are available by which we are able to see that how the radiation for a particular year varies from the day to night and for the different month as well. So as you can see that we have captured this for a Noida case where for the different month the solar radiation is captured and we have plotted like this, which will be very useful to do the further designing on the solar plant. And these are the important aspects when we carry out the solar plant feasibility study. This one is a very important aspect of doing kind of a hand calculation, you can say, or basically you can say a very typical example where we are able to convert the actual radiation, irradiance. Like in the left side figure, you can see from 7 a.m. to 6 p.m. we are able to generate 1 kilowatt per meter square, but at a different intensity. Maybe at 7 a.m. we were having almost a zero or few intensity, but maybe at 12 o'clock or 1 o'clock we will having a high intensity, maybe
हेलो
1000 watt per meter square.
हेलो
But it can be
हाँ
converted.
बोलिए सर.
This can be converted into a kind of a normalized irradiance. Ultimately, what we are trying to say that the Gaussian curve which you are able to see on the left hand side is having a total energy, and the same energy if we plot in a rectangular form, which is basically having an amplitude of 1 kilowatt
आप
per
किनसे
meter
बात कर
square.
रही हैं? हेलो.
So when we plot on the right hand side this particular total energy in the form of a rectangle, then in that sense the whole 12 hour of 7
हेलो.
a.m. to 6 p.m.
ये गलत नंबर लगा रहे हैं आप. हाँ.
So this whole energy of 7 a.m. to 6 p.m. can be converted into a rectangular form in the sense that 1 kilowatt energy for 5.5 hours. So in the sense, it is very handy to understand, very handy to use also. Solar energy may basically, if you want to use it very handy, then in that case, what we can do, the Gaussian energy can be converted into a 1 kilowatt per meter square for 5.5 hours. तो आप ये देख सकते हैं कि जैसे सपोज करो अगस्त का महीना है एंड देयर इज अ लॉट ऑफ रेन इन द मंथ ऑफ अगस्त से फॉर एग्जांपल, then you will not be in a position to get the kind of a total solar energy for 5.5 hours. You may be able to get energy for, say, for example, 1 kilowatt hour in total in cumulative manner, you can say, for, say, for example, 3 hours. But when you do consider this similar case for the case of April, maybe you will find that for a particular day, you will be able to get 1 kilowatt for 5.5 hours. So ultimately, you are in a position to compare a one particular day of April with a one particular day of August. That in this particular day you will be able to get a 5.5 घंटे की एनर्जी मिल जाती है और अगस्त में हमको 3.5 घंटे की एनर्जी मिलती है. So this is a very important and beautiful concept where we are able to capture the whole energy from you can say in the Gaussian curve which left side में दिख रहा है उसको हम एक स्टैंडर्ड फॉर्मेट में 1 किलोवाट पर मीटर स्क्वायर में कन्वर्ट करके कैप्चर कर लेते हैं. And then using this particular format is very helpful in doing all the calculation when we are doing these things. Solar PV module, we all know that we have to have a solar PV with a PN junction where we have to have some kind of a silicon doped with a lesser electron and more electron kind of a thing, like boron and phosphor. And in that sense, we are able to produce a kind of electric field. And because of that electric field, when the photon energy falls on the panel, that photon energy converts or dislodge kind of electron, create holes. And because of this electric field, this electron flows, and that flows in the form of a current, and then current basically flows in, which will be used for the purpose of generation of electricity. So the concept is straightforward in the case of photovoltaic, but there are several things which need to be understood that why the solar cell, how the solar module, and all those comes into picture. And if you go into the further deeper part of the any solar cell, then there is basically a concept of solar PV characteristic. The characteristic is basically called the IV characteristic, that is the current voltage characteristic. Maybe many people may be knowing this also because this is a fundamental concept of any solar plant. In that, you will be saying that on the vertical axis, we are having the current, and on the horizontal axis, we will be having the voltage. And then we are able to plot kind of a voltage and current characteristic. And then there is a point called knee point. Which is called the maximum power point, because you must understand that to generate a power, both current and voltage should be there. So if we try to find out that what is basically the ISC, then you don't have voltage, only current. Similarly, the VOC, that is the open circuit voltage, then you don't have any current, only voltage is there. So there will not be any kind of a power generation until unless we will be in between these 2 points. And the maximum point is basically called the knee point, which is called the MPPT point also, maximum power point transfer point. And that maximum power point transfer point is called the knee point. This point also gives us another concept of fill factor, which is basically the area 2 upon area 1. तो डिफरेंट सोलर का जो मैन्युफैक्चरिंग होता है उसमें फिल फैक्टर एक इम्पॉर्टेंट कंसेप्ट का काम करता है, in the sense that when we have a good fill factor, then at least you are able to capture more energy from a given solar cell. And ultimately the area 1 is VOC into ISC, which is a bigger area, and VMP in IMP is the P max, which is we are able to get it. So area 2 by area 1 is basically the fill factor, and this fill factor is the main characteristic of any solar cell. And this maximum power point is important aspect because this is the maximum power which we can get from any solar module. अब इसमें basically there is a possibility that we have a higher temperature, like standard test condition की हमने बात करी थी. In that standard test condition, we are able to get the maximum power. But if the temperature goes high, then in that case, either VOC and ISC will be reduced. Similarly, the 1000 watt per meter square, if you are not getting the radiation, then in that case, your ISC will be lower. Then you will be having at a different ISC value, and then your power will be lesser. So ultimately, when we talk of VM and IM, this is the maximum voltage, this is the maximum current which we can get. And according to that, the maximum power which we will getting VM and IM. And that is basically we define the fill factor from this thing. So this is the standard concept of this solar cell. Likewise, if you want to calculate the kind of a efficiency of the solar plant also, like a solar panel or solar cell also, here also you will see that suppose a solar cell is basically having an area of 156 mm by 156 mm. And that basically is the incident energy which we are talking is standard test condition के point of view से this is 1000 watt or 1 kilowatt per meter square. So 1 kilowatt per meter square falling on 0.156 meter square basically is almost 24 wattage. But however, the voltage VMP and IMP which we are getting is almost 3.5 watt. So by that way, we are able to get the cell efficiency as 3.5 watt by 24, almost 14.38%. So it is very important that when we talk of efficiency of the solar module or solar panel, it is basically the cell area which is able to convert the radiation into a proper energy form, wattage. If you are having a same area and you are able to convert more output, then your efficiency will be higher. So it is very different from the efficiency of many other systems where you are giving the input, you are getting the output, and output upon input is basically the efficiency. But here the area of the particular solar cell is getting very important. And if that area is giving you the most major lead, the more yield from that particular area, you will having a major higher efficiency. So in newer system, you can find that you will be getting the higher efficiencies as well. And second important aspect is the temperature effect. Temperature effect is very important to understand that when the temperature goes high, then in that case, the VOC decreases, the voltage decreases. And because of that, the temperature, higher temperature, the module or the solar cell generate lesser. So that's why we generally see that the portion like Ladakh area where the temperature is also low as well as the radiation is also good, then you are able to generate more. Whereas in the case of Rajasthan, although we are having a lot of solar plant installed in Rajasthan and Gujarat because the radiation is very, very high there. But at the same time, if we consider the temperature aspect, those are the area where basically we are losing on temperature part. And that's why the temperature coefficient of any solar module is also very important. The temperature coefficient is generally, is always basically is the negative temperature coefficient. That means whenever you are having any kind of a temperature high, you will be reducing lesser. And that is the temperature effect on the solar part of solar cell. Ultimately, when you connect the different solar cells, you will be getting the solar modules. It can be connected in series, it can be connected in parallel. The different component of the module, you can see that there is always a frame, then there is a glass, then encapsulant, then there will be a layer of solar cell. Below also the encapsulant will be there. Then back sheet is there and the junction box is there. And we are always getting a different type of combination. Like sometimes we are getting 72 cells arranged in a series parallel, 60 cells arranged in a series parallel, 36 cells. So different type of solar module we are able to get it. And it is also important that no two solar cells are same in any case, because ultimately when we are manufacturing the solar cell, there is always a basically kind of a perfection level where we are able to get it. So when we are combining two solar cell in the form of a parallel or series, we will be always having some kind of a mismatch. So when the solar cell are basically connected in parallel, then VOC is having the voltage is having an impact. Similarly, when you are connecting in series, then definitely one is generating more current, other is generating less current. Then the less current will taking the lead because it will not allow the other to go for that higher current. So ultimately, there will be a mismatch loss. Now, it is very important to reduce the mismatch. And that's why the concept of binning is very important when we are making any kind of a solar module. The binning means that we are trying to identify similar type of solar cell where the difference in the voltage and current are lesser. And type of binning will basically make the mismatch losses lesser and lesser. And that is a very important concept which is basically used by most of the manufacturers. So this is a typical, you can say, data sheet of solar cell where you will be having a power rating, you will be having a open circuit voltage, short circuit current, then the temperature coefficient, which I was just mentioning. The temperature coefficient for power is always there, which is minus 0.43, like this is basically the number. So temperature coefficient is always in negative because it ultimately reduces the power when the temperature goes high. So this is a typical data sheet of the, and you on the right hand side you can see that either solar cells are series connected or parallel connected, and ultimately leading to the maximum power point. This thing. Now, ultimately coming back to the technology part, there is a lot of advancement is happening in the solar part. Now, there are solar cell which are generally called the first generation solar cell. Right from the beginning stage, these are available: crystalline solar cell, multi-crystalline solar cell. Then there are second generation also, where thin film basically came into picture, which is like a CAGS, CDT, amorphous silicon. Different type of second generation solar cell came. And now we are talking of third generation solar cell also, like organic PV, multi-junction solar cell, quantum dot solar cell, perovskite solar cell. So there are several type of generation evolution of solar panel or solar modules are happening. Ultimately, the advancement is happening in multiple stages. One is on the cell technology, that is like PERC technology, passivated emission rear contact. Then the size of wafer is increasing. Then the bus bar where the current flow, that is also getting changed. Similarly, on the module technology, if you talk of, there are several type of module which are coming up, which are having a bifacial. They are basically able to generate from the both faces, from the top also, from the bottom also. Because whatever solar energy is getting reflected from the earth, or you can say the flat area, that can also generate the power. So that is called the bifacial, both sides. Similarly, the half cell concept is that cell is divided into two parts and then it is connected so that we can reduce on the losses. Thin film. So there are several module technology which are getting advancement. Then it comes to the systems. Systems is basically like ground mounted system we are talking of in a standard manner. Rooftop systems we are talking of. Floating PV is we are talking of. Building integrated, where it is integrated with the building. Then another advancement is happening on the performance improvement. Like it is very important that dust on the water solar panel to be removed. Now that can be removed with the either through the water cleaning, or we can have a robotic systems which can clean the panel by means of water or by means of dry cleaning. Degradation study is very important. Every year, basically, the module degrades, and in the span of 20 years, it degrades almost 20%. And this is called the life of the solar panel also. Now, whether this is actually degrading in the same manner which is as per the design, or it is degrading in a faster manner, or it is degrading in a slow manner, so all those degradation study is also equally important, so that we can get the return on investment which we have done for any installed plant. We understand that when we talk of manufacturing cycle of any PV module, it starts from the polysilicon, then it comes to the ingot to wafers, wafer to solar cell, and solar cell to PV module. And then there are several solar cell technology which has been evolved. When we start with the crystalline silicon, in between the thin film also came up, the cadmium telluride kind of a thin film, which is very popular. These are the technology I am basically chosen, which are commercially available. There are several technology which you may be reading in the academic books, which are very important also as well. But these are the 4 5 technology why I'm discussing is because it is commercially available and it is being used by the users, and it is being produced in the very big number manufacturers. So like when we talk of cadmium as a telluride, that is a thin film type of technology. In last 4 5 years, there are a lot of advancement in had gone into a PERC technology. PERC technology is basically the passivated emitter rear contact, in which basically there will be a kind of a passivation layer. Ultimately, that layer will important. Why? Because it will reduce the recombination, and when we reduce the recombination, you will be ultimately increasing the current, and that is kind of a different technology, PERC technology, which is being used. And this type of PERC panels are almost installed in last 4 5 years in huge number. But nowadays, another important technology which is coming up is basically the TOPCon technology, which is, you can say, the tunneling oxide, this contact technology. The tunneling oxide is basically, you can say that there will be a kind of a silicon oxide layer, which is in the so thin that it forms a kind of a tunnel. Ultimately, in most of the cases, what we are trying to do is that we are trying to reduce the kind of a recombination. We are trying to restrain the minority carrier. We are trying to increase the majority carrier. and we are trying to improve the efficiency. Efficiency, when we talk of, ultimately we are trying to increase the yield from a given piece of cell. So that yield can be increased by way of reducing the losses only. And that losses means we are about trying to get more and more magnetic area to flow into the an electrical path. So like in these type of different technologies, the important aspect which I just mentioned is that in case of temperature coefficient, if we take for example, when we talk of cadmium, this crystalline silicon, the temperature coefficient was almost minus 0.45, 46, or even sometime minus 0.5 kind of a thing. Now, it is very important to 0.45 to almost 0.3, minus 0.3%. So that when the temperature goes high even, then also we are able to generate more. Similarly, in case of LID, there is another concept called LID. That is basically the light-induced degradation. The light-induced degradation is that when you just first time put the module onto the sun, there will be a light falling on the module, and immediately there will be some kind of a degradation, which is very different from the regular degradation. Now, in case of N-type TOPCon technologies, we are having a lesser LID effect, lesser LID losses. Similarly, degradation coefficient is also decreased from minus 0.7% to minus 4%. So ultimately, there are technologies in innovation and advancement which are happening, and this N-type TOPCon is basically getting important. So just repeating those things, that kind of a numbers which we are getting in the case of monoPERC or TOPCon technology is very good number, efficiency number. And in N-type TOPCon technology, almost 26% of efficiency we are able to achieve because of all these factors. Like LID हमने कम कर लिया, हमने उसका temperature coefficient बढ़ा लिया, so and at the same time हमने उसका efficiency improve कर लिया. So those all aspect is with the help of TOPCon technology is we are able to give. Now you must be seeing that there is a P-type or N-type kind of a concept. There was, when we are talking of PERC technology, generally P-type basically is the concept which is being used. It is basically a PN junction. When we are forming the PN junction, one is acting as an emitter and other is acting as a substrate. So when the substrate is P-type, it is called the P cell design. When the substrate is N-type, it is called the N-type substrate design. इनिशियली हमेशा बेसिकली क्या है कि एन टाइप सबस्ट्रेट लेने में हमको एडवांसमेंट और एडवांटेज मिलता था, बट बिकॉज द टेक्नोलॉजी मैन्युफैक्चरिंग इज सो कॉम्प्लेक्स, people have not entered into that particular concept of N-type technology. But now with the advancement in the manufacturing line also, this N-type is also come into picture, and N-type TOPCon cell design is very much popular now, and which is available with a very high efficiency of solar cell. So this is a just comparison. You can see that P-type and N-type module rating is available. तो आप देख सकते हैं कि मॉड्यूल डायमेंशन को यदि हम पिक्चर में ले बेसिकली विद द मॉड्यूल डायमेंशन ऑफ दिस मच नंबर 2465 on one side, 1134 on another side, and thickness of 34 mm, we are able to get almost 635 watt peak kind of a module in case of N-type with a weight of 30 kg almost. तो दिस गिव्स अस इन अ लेसर एरिया हम ज्यादा लगा सकते हैं. जैसे आज से 10 साल पहले, 15 साल पहले हमने कोई 300 वाट का या 250 वाट पीक के पैनल लगाए हुए हैं सपोज करो, एंड इफ यू ट्राइंग टू रिप्लेस दोस पर्टिकुलर मॉड्यूल विथ 635 वाट पीक मॉड्यूल, सेम एरिया में वी आर एबल टू जनरेट मोर, एंड दैट इज द ब्यूटी ऑफ हाई एफिशिएंसी विच इज हैपनिंग इन द सोलर इंडस्ट्री. So this is the concept of industrial aspect of understanding these nuances of the solar plant. Another concept is coming up like HGT solar cell, heterojunction solar cell, which is also getting popular. So TOPCon, HGT, and PERC, these are the three technologies which are gaining momentum, and these all three technologies are having been manufactured by different people. On the right side, what I am trying to show you is that the bifacial, where basically we are having both sides, we are able to generate power from the top side and also from the bottom side. So as you can see, the bifacial modules are offering lesser, basically capturing more energy, because on the reflected sunlight from the rear side, जिसको हम albedo भी कहते हैं, जो हमारा solar energy fall कर रहा है, when it gets reflected from any reflector, like Earth is basically one kind of reflector. So from that reflector, the sunlight is reflecting, and when it reflects, it gets fall on the back side of the solar module, and you get the power because of that as well. Likewise, on the top side, you are always getting the power fall on the front surface. So by bifacial system, say we are able to generate almost 16 to 20% more when we talk. But the important part is that the rear side should be a good reflector. Like यदि आप suppose करो कोई greenery है जहाँ पे बहुत ज्यादा, वहाँ पे if you start trying to install the bifacial panel, then you will not get good reflection. But if you call it a rooftop system where you have a very smooth roof available on that thing, and if you install this type of bifacial module on the roof, then you will be having a good reflection from their roof, and that will give you a good energy on the back side also. Even people are using a paint, reflecting paint also on the roof of their building, so that they will get a good reflection from there when they are using the bifacial module. And the half-cut solar cell is basically you are cutting the solar cell into two parts and then again arranging it in the kind of a module by which you are able to reduce the current losses in a particular cell, and you can increase the total generation from solar cell. So as you can see that over a period of 20 years, almost we have reduced from 2,200 watt peak to 20 watt peak, and the efficiency has increased from 10% to almost 26% by means of various various kind of a technological advancement. And ultimately, where exactly we are going to use this technology? We have to use this thing into a very big size of a utility scale solar PV plant. In one single location, we are basically installing a 30,000 megawatt of solar plants, which is a run of Kutch area in Khavda district of Kutch. I was the head of project there in run of Kutch, and we are installing 30,000 megawatt of solar plant in the desert area of run area of Kutch area. And NTPC, Adani Power, and many other companies are installing such type of solar bigger plant. So which is basically a utility scale solar plant when we call it. It is basically a big plant where we are able to generate a big number from this solar plant. So solar plant is basically a facility where we are able to convert the power, solar energy to the power. And these panels generally generate the DC energy. From DC to we convert into the AC. And plant size can vary from the small installation to bigger installations. The important component, if you talk of any solar PV system, is that उनका एक mounting array होगा, then there will be a mounting hardware. There will be a structure on which we will be mounting. There will be a junction box, panel junction box, field junction box, circuit breakers, surge protection devices होंगे, lightning arresters होगा, AC distribution boxes होंगे, then module interconnection cables होगी, then power conditioning unit or inverters होंगे, basically power transformers होंगे, and the pyronometer is basically to measure the radiation. Pyronometer is a device which used to measure the GHI, global horizontal irradiance, GHI measure करने के लिए. So that will also be there. It is a typical rooftop system of 110 kilowatt. If you can see that in the roof 1 and roof 2, we have installed the panel. Then from that, it is coming to the SMB. SMB is string monitoring box, where all the different strings are getting arranged or connected. And then it will go into the array junction box. From array junction box, it will go to the inverter. Inverter will convert this DC power into the AC power. And the AC power will go into the LT panel. And from LT panel, it will go to the grid. So ultimately, we will be also having a SCADA or the PLC device from where we can monitor everything. And then weather station is also important, जहाँ हम अपना solar radiation measure करेंगे, and at the same time we will measure the temperature and other parameter as well. Another important aspect is basically where we don't have the lands available. Like there are plenty of area in India which is basically very much agriculture in nature. Land is agriculture in nature. Using this agricultural land into the solar panel is basically, you can say, a kind of a crime, because ultimately agriculture is most important aspect. But there are concepts where we are able to use the water bodies. So if we can install a solar plant on the water bodies, then we are able to generate a power, as well as the water cannot evaporate also. Water will not evaporate. So we are able to we will be able to reduce the water evaporation as well. And third important aspect is that because the water is below the panel, there will be always a cooling effect. And because that cooling effect will give us more power, because ultimately, as I told you, that the temperature coefficient is always a negative number. And when the temperature goes high, module generate lesser. But because of this cooling effect, module will generate more. So the floating PV is basically one such technology which gives us a multiple advantage, which gives us the land saving, which gives us the water saving, and which also give us the more generation, because it is basically having a temperature cooling effect. With these three concepts, we have come up with this floating concept. In NTPC itself, we have from 2014 onward, we are working in this technology. I myself was involved when I was in research and development team, and we had a MOU with CPET, Central Institute of Plastic and Engineering Technology, where we have developed our own floaters. We have taken the patent as well on this thing. And those basically has been developed in-house within NTPC as well. And right now we have installed a very big plant in the various water bodies of our thermal plant even. So if you the scheme of floating PV, if you want to understand, that there will be a PV modules floating on the water body, then there will be an inverter. From inverter, it will go to the transformer and the grid. So these are the different component of the floating PV. The PV module is there, inverter is there, floating structure is there, transformer, SCADA, cables. If you can see that cable is also floating, and the anchoring and mooring system. The anchoring and mooring system is very, very important, because you know that when the floater is floating on the water bodies, it is basically liable to wave variation as well as depth variations and all those stuff. So it is very important to tie this floaters either at the side or at the bottom of the any reservoir, and that is called the anchoring and mooring system. We are carrying out various studies also. So if you can see, when we talk of floating system, it is very important to understand the what is basically the ground soil composition or the bathymetry of the any reservoir. Bathymetry means what is the surface of the water body, because in various cases you can find that there is a lot of undulation in the surface, or there is the soil composition is so loose that you cannot hold any kind of anchor in that. So that type of study is very important in terms of bathymetry and soil study. And parallel to that, we need to understand कि कितना वेव उसमें ऊपर नीचे होता है, कितना बेसिकली उसका साल भर में लेवल नीचे चला जाता है या ऊपर चला जाता है. These all are very important aspect of floating PV. Like in case of a dam area where basically the hydro plant are installed, we can install such type of technology. But we need to take care is that in case of a dam, the water level surface will go down to almost 15-20 meter variation is there, water level variation. So for that, we need to have arrangement of mooring and anchoring system in such a manner that this system will remain in that location itself. तो दिस आर वेरी चैलेंजेस आल्सो विद रिस्पेक्ट है. जैसे एनटीपीसी का मैं दिखाया हूँ आपको, इन वन लोकेशन इटसेल्फ वी हैव इंस्टॉल 100 मेगावाट ऑफ सोलर प्लांट इन अवर रामागुंडम प्लांट. लेफ्ट साइड में आप रामागुंडम प्लांट देख रहे हैं. द ब्यूटी हियर इज दैट ऑलमोस्ट द ऑल इलेक्ट्रिकल सिस्टम लाइक ट्रांसफार्मर्स, इन्वर्टर्स, एवरीथिंग इज ऑल्सो फ्लोटिंग ऑन द वाटर बॉडी. And that is basically our Ramagundam plant where 100 megawatt is installed. Similarly, this Ramagundam is in Telangana. Similarly, Simatri plant basically in Andhra Pradesh, there also we have installed 25 megawatt. Kayamkulam is basically in Kerala where we have installed 92 megawatt. So we have already installed more than 260 megawatt of floating solar in different locations. In most of the thermal plant, actually we store the water. And that water is basically, we need to avoid the evaporation as well, water losses also. So this is a win-win situation for any thermal plant also. Wherever you are storing the water, you can install the solar plant on the water body, by which you can able to generate. You are not able to, you are not using your land. You are able to get good generation because of temperature effect. So this is concept is a success story, you can say, for a country like NTPC, company like NTPC. And then basically comes the another component, solar inverter. You must be knowing that solar inverter is very important component where basically we are converting the DC power into the AC power. There are different concept of solar inverter. सेंट्रल इन्वर्टर की तरह भी यूज करते हैं, हम इनको स्ट्रिंग इन्वर्टर की तरह भी यूज करते हैं. द सेंट्रल इन्वर्टर इज जनरली इन द साइज ऑफ 2 megawatt, 3 megawatt, 4 megawatt kind of a thing, whereas the string inverter are generally in the band of 200 kilowatt, 300 kilowatt. So it is very important. There are always basically advantage and disadvantage when we are using the string inverter or the central inverter. In some of the cases, string inverter are very useful because when one string inverter fails, still you are able to generate more because only one portion is failed. Whereas if you lose one central inverter, you will be losing directly 2 megawatt or 3 megawatt kind of thing. But at the same time, there will be a lot of cabling involved in the case of string inverter. So there is always basically a design aspect which needs to be looked into. एक और aspect है basically कि आपका suppose करो land बहुत ही undulated है, बहुत ही ऊपर नीचे है suppose करिए, तो उस केस में यदि आप central inverter लगाते हैं, then there will be always a loss because in one cases you will be having a higher generation, in one case you will be having a lower generation, and then you are mixing those things and the lower generation will basically prevail. And because of that, the central inverter is not a good suggestion. But string inverter, because in every pocket you are using a small inverter, you will be able to generate more. So there is always a kind of a selection criteria where we are able to select string inverter or the central inverter in case of a design of any systems. So these are the different type of string and central inverter का concept है basically, जिसमें इसको कैप्चर किया हुआ है. Another important aspect is basically the DC-AC ratio. ये एक बहुत important concept इसलिए आया पिक्चर में basically कि when we are installing the solar plant, तो solar plant हमेशा बेसिकली 1000 watt per meter square तो बेसिकली रिसीव नहीं करते हैं. दे आर रिसीविंग समटाइम्स 200 watt per meter square, दे आर रिसीविंग समटाइम्स 400 watt per meter square, and for very few hours, half hour or 1 hour, they are getting almost 1000 watt per meter square kind of a thing. So when we are designing the complete system with 1000 watt per meter square, and when we are not getting that type of radiation all the time, it is always advisable to install more panels and with a same inverter of like 1 megawatt inverter के साथ आप 1.5 megawatt के solar module लगा दीजिए. तो होगा क्या basically कि you are able to generate more and you are able to utilize the inverter also more because 200 watt के समय पे you will be basically getting the 300 watt के आसपास का power generate करोगे DC side में. So this is called the DC-AC ratio. It is a very important concept which has come up, and that basically lead to a solar plant of, say for example, when we are talking of 100 megawatt, not 100 megawatt peak, 100 megawatt solar plant यदि हम बात करते हैं, तो प्रैक्टिकली पीछे एक्चुअली 150 मेगावाट पीक का सोलर प्लांट लगा हुआ होता है. इन्वर्टर 100 मेगावाट का ही होता है, बट अल्टीमेटली वी आर एबल टू रिड्यूस ऑन द इलेक्ट्रिकल सिस्टम्स and we are able to generate more during the hour when the solar radiation is not close to 1000 watt per meter square. तो मॉर्निंग आवर्स में, इवनिंग आवर्स में आप क्या करते हैं बेसिकली कि आप ज्यादा जनरेट कर सकते हैं बिकॉज आपने डीसी साइड ज्यादा लगाया हुआ है. तो ये एक कॉन्सेप्ट है जो डीसी-एसी रेशियो हमेशा डिजाइन में यूज होता है. और इस तरीके से बेसिकली गुजरात का ये हमने एक लोकेशन कैप्चर किया जिसमें डीसी-एसी रेशियो 1.25 था और ऑलमोस्ट 31% का कैपेसिटी यूटिलाइजेशन फैक्टर हम गेन किया था. एक और इम्पोर्टेंट कॉन्सेप्ट है ट्रैकर का. आपने सुना होगा बेसिकली समटाइम्स सोलर प्लांट इंस्टॉल ऑन द फिक्स ट्रैकर और द सिंगल एक्सेस ट्रैकर और ड्यूल एक्सेस ट्रैकर. ड्यूल एक्सेस ट्रैकर का मतलब है बेसिकली यू आर ऑलवेज फेसिंग द सन. सिंगल एक्सेस ट्रैकर का है यू आर फेसिंग द सन ईस्ट टू वेस्ट, and the fixed tracker ka you are not facing the sun at any time. Whenever basically sun comes on the top you will be facing it, otherwise you will just fixed type install. So there is always an advantage and disadvantage with the different type of tracking systems. Fixed tilt में ठीक है मेंटेनेंस बिल्कुल नहीं होगा, बट सिंगल एक्सेस ट्रैकर में मेंटेनेंस होगा, एंड एट द सेम टाइम डुअल एक्सेस ट्रैकर में भी मेंटेनेंस और ज्यादा होगा. So when we are discussing on this particular aspect of single access and dual access tracker, it is understood that आज की डेट में जैसे मॉड्यूल का कॉस्ट काफी कम होता जा रहा है, तो when you are having a lesser cost of the module, you can definitely go for a tracker system बिकॉज अल्टीमेटली जो कॉस्ट ट्रैकर में आपकी इंक्रीज हो रही है वो मॉड्यूल में आपकी डिक्रीज हो जाती है, कम कम हो जाती है। तो जैसे जैसे आपका मॉड्यूल कॉस्ट, अदरवाइज बेसिकली इट इज इफ द मॉड्यूल कॉस्ट इज वेरी हाई, then in that case using the tracker system is advantageous. When the module cost is very low, then going for the fixed access system is advantageous. Because जब आप मॉड्यूल कॉस्ट बहुत हाई है तो आप क्या चाहोगे, लेसर मॉड्यूल लगाने पड़े मुझे और ट्रैकर सिस्टम के साथ मैं ज़्यादा एनर्जी गेन कर लूँ। So it is always important to design in the sense how basically we are able to use different type of systems. दो important aspect हैं basically, one is the capacity utilization factor and one is the performance ratio. कैपेसिटी यूटिलाइजेशन फैक्टर की बात करें हम लोग तो बेसिकली टोटल साल में जो एनर्जी हम निकाल रहे हैं इंस्टॉल्ड प्लांट से, दैट इज कॉल्ड द कैपेसिटी यूटिलाइजेशन फैक्टर विच इज जनरली इन द बैंड ऑफ 25% to 30% काइंड ऑफ थिंग। तो अल्टीमेटली हमारा इंस्टॉल्ड कैपेसिटी 100 मेगावाट का है सपोज करो, उससे कितना एनर्जी हमने निकाला है, दैट एनर्जी डिवाइडेड बाय इंस्टॉल्ड कैपेसिटी इंटू 365 into 24 hours will give us the capacity utilization factor from that particular plant. यदि थर्मल प्लांट की बात करें तो थर्मल प्लांट बेसिकली हमको 90% तक की कैपेसिटी सीयूएफ भी देता है, बट सोलर प्लांट बेसिकली लिमिटेड है अपने सनी सनी आवर्स के लिए, 8 ही घंटे आपको अल्टीमेटली सोलर पावर मिलेगा। तो इसलिए ऑलमोस्ट उसका 1/4 25% 26% के आसपास हमको एनर्जी मिलती है, विच इज बेसिकली कॉल्ड द कैपेसिटी यूटिलाइजेशन फैक्टर। तो ये एक इंपॉर्टेंट कॉन्सेप्ट होता है जब हम किसी भी प्लांट को अंडरस्टैंड करना चाहते हैं। But apart from that, there is another concept which is called the performance ratio. A performance ratio is very different from the capacity utilization factor. Generally, लोग confuse होते हैं CUF में और performance ratio में। PR is basically the total loss in your system. आप modules लगाते हैं, पर modules ultimately to the electrical energy going into their electrical cables or electrical grid is basically having a some losses, cable loss, mismatch loss, likewise dusting loss, soiling loss. There are several losses are there. If we include all those losses and then get how much energy we are getting it finally is basically the performance ratio. Generally 75% to 76% performance ratio होता है, that means 25 to 25% हम लोग लॉस करते हैं। This is generally a concept where basically the economics of PV is coming to picture. Module cost is major component. Then inverter is also having a one component. Module mounting structure is having a good bigger number. So this is the breakup of cost breakup of a solar module. But the important part is that how the tariff, जैसे हम बोलते हैं बेसिकली कि सोलर एनर्जी 2 रुपए पर किलोवाट आवर हो गई है, 3 रुपए पर किलोवाट आवर हो गई है, तो उसमें बहुत सारे फैक्टर काम करते हैं। एक फैक्टर काम करता है बेसिकली आपका कैपेक्स कितना लगा, उसमें कितना करोड़ का खर्चा आ रहा है। देन उसके अलावा बेसिकली उसका एनर्जी कितना निकल रहा है, जो मैंने सीयूएफ बताया था कैपेसिटी यूटिलाइजेशन फैक्टर कितना, उससे हाउ मच एनर्जी वी आर जनरेटिंग, हाउ मच लॉसेस वी आर हैविंग। एंड देन अपार्ट फ्रॉम दैट ऑन द फाइनेंशियल एस्पेक्ट में बेसिकली कितना रेट इन्वेस्टमेंट पे रिटर्न आप ले रहे हैं, दैट इज वन एस्पेक्ट। एंड देन कितना O&M एक्सपेंसेस हो रहा है वो, एंड देन हाउ मच बेसिकली लोन आप जो उठा रहे हैं उस पर कितना रेट ऑफ इंटरेस्ट है। ये ऑल कैप्चर करते हुए वी जनरली कम आउट विद अ नंबर विच इज कॉल्ड द लेवलाइज कॉस्ट ऑफ एनर्जी। The levelized cost of energy is called the tariff of that number. So when we calculate the 2 rupees per unit or 3 rupees per unit kind of a solar energy, this is basically a financial model where we need to include the technical aspect, how much is the module cost, how much is the inverter cost. Then second is we need to include the land cost. Then third, we need to include the return of investment, ROE basically. Then fourth, we need to include the loan interest rate and all those expenses. And then fifth, we need to include the O&M, how much we will be basically using the O&M in that. इन सभी को फैक्टर इन करते हुए we generally come up with the tariff which is called the levelized cost of electricity. Generally ये tariff जिसको बोलते हैं हम लोग। And the major factor of any tariff is definitely the capex जो आप खर्चा कर रहे हैं। देन कितना जनरेशन उससे हो रहा है, एक सेम एरिया में आप जनरेशन ज्यादा करते हैं तो डेफिनेटली आप ज्यादा एनर्जी निकाल रहे हैं। देन वैक इज बेसिकली आपका रिटर्न ऑन इन्वेस्टमेंट एज वेल एज योर रेट ऑफ इंटरेस्ट एंड O&M पे कितना खर्च है। दीज आर द टैरिफ ड्राइवर फॉर एनी नंबर टैरिफ टू कम आउट। लास्ट चैप्टर बेसिकली आ जाता है डिग्रेडेशन का, जिसको कि जस्ट आई कंक्लूड दिस प्रेजेंटेशन एज वेल। डिग्रेडेशन इज वेरी इंपॉर्टेंट एस्पेक्ट। लाइक अब सब कुछ कर लिया हमने, प्लांट लगा लिया, अपना प्लांट लगाने के बाद हमने उसका टैरिफ भी निकाल लिया, सब कुछ कर लिया। आफ्टर दैट when we are operating this plant, operate करते समय what we could find is that the module which is basically supposed to degrade in some fashion, it is not degrading in that fashion, but it is degrading much severe. Then what will happen? Whatever energy basically generation which we have taken at the time of calculation of the tariff, that is not coming up. उतना एनर्जी हमको मिल नहीं रहा है. उतना एनर्जी नहीं मिलेगा तो आपका टैरिफ बेसिकली ऑल्दो आपको 2 रुपए ही मिल रहा है, लेकिन आपको लग रहा है 3 रुपए का टैरिफ, 2.5 रुपए का लग रहा है. So that means the degradation is one important aspect which we need to regularly monitor, and we see that whether this degradation is happening in the manner which is basically taken at the time of design. If it is not happening in that design, we need to find out what is the basically failure modes. क्या क्या failure ऐसे हो रहे हैं जिसके चलते कि ये इस तरीके का हो रहा है. That is basically called the degradation study, and we need to find out that degradation rate कितना है, कितना उसका degradation होना चाहिए था, वो degradation rate आज की डेट में कितना चल रहा है. We need to develop the history of this degradation, and इसके लिए हमको डिफरेंट टेस्टिंग करनी पड़ती है. देर आर सेवरल मीन्स ऑफ टेस्टिंग ऑफ दिस मॉड्यूल. टेस्ट करने के लिए देर आर टेस्ट विच कैन डन, इंडोर टेस्टिंग कर सकते हैं, आउटडोर टेस्टिंग कर सकते हैं. देर आर सेवरल इक्विपमेंट्स विच आर अवेलेबल, लाइक थर्मोग्राफी है टेम्परेचर मेजरमेंट करने के लिए, पोर्टेबल आईवी कैरेक्टरिस्टिक है जो पावर मेजरमेंट करने के लिए. देन इंडोर इंस्ट्रूमेंट में जैसे इलेक्ट्रोलुमिनेशन सिस्टम है बेसिकली विच गिव्स अस काइंड ऑफ ए माइक्रो क्रैक्स इन द मॉड्यूल. माइक्रो क्रैक्स बढ़ते जाएंगे तो डेफिनेटली डिग्रेडेशन फास्ट हो जाएगा. सोलर सिमुलेटर होता है जिससे बेसिकली हमको आईवी कैरेक्टरिस्टिक मिलती है उसकी. So ultimately, this all leads to give us a inside picture that how the degradation is happening and whether we can reduce this degradation by some means so that our return on investment will come up according to what we are basically planned. And the last point is also the cleaning system. आप देखेंगे मॉड्यूल के ऊपर इतना मोटा मोटा डस्ट जमा हो जाता है. डस्ट जमा होते ही बेसिकली जो जनरेशन उससे एक्सपेक्टेड है जैसे वी आर नॉट एबल टू अचीव. एंड व्हेन वी आर डूइंग ए मैनुअल क्लीनिंग, इतने बड़े बड़े मॉड्यूल्स, इतना जैसे रन ऑफ कच्छ का एरिया हम दिखा रहे थे आपको, व्हेन वी आर ट्राइंग टू क्लीन सच टाइप ऑफ ए मॉड्यूल बाय मैनुअल क्लीनिंग, पानी डाल के उसको साफ करना, इट इज ऑलमोस्ट नॉट पॉसिबल. Then there comes the robotic cleaning system. Robotic cleaning system you install on the panels. They will do the cleaning as and when required. जब भी आपको चाहिए आपने चला दिया, उस समय क्लीन हो गया. Then कोई डस्ट स्टॉर्म आया है उस समय पे ऑल मॉड्यूल गेट कवर्ड विद द डस्ट. लाइक जैसलमेर में, राजस्थान में डस्ट स्टॉर्म आते रहते हैं, सारा कवर हो जाता है एक ही बार में. आपने रोबोटिक क्लीनिंग सिस्टम चला दिया, दैट रोबोटिक क्लीनिंग सिस्टम विल क्लीन द कंप्लीट मॉड्यूल and you are able to generate according to what is expected. So these are automation is very important aspect of to get our return of investment ultimately. So to conclude, the key takeaway is that the solar PV is a very growing technology field जिसमें आप देख रहे हैं कि life enhancement and the efficiency improvement, these are the two important aspects which are continuously happening in this case. And module is most important component which we need to look into. Various type of installation is possible: rooftop, ground mounting, floating, and similarly the performance ratio and capacity utilization factor, ये दो important factor हैं basically which we need to capture. And last but not the least, the module testing, degradation, life assessment, these are the important aspects, and we should, in all the colleges and schools, basically we should have understanding about various type of instrument which can be used to improve the performance of any systems. हम क्या है बेसिकली वन एस्पेक्ट देखते हैं मॉड्यूल का, मैन्युफैक्चरिंग एस्पेक्ट. सो वी कीप ऑन putting kind of a manufacturing line and all those stuff, but the other part is also very important. When you install the plant, it is very important that we need to run it properly so that the kind of degradation, the kind of losses which we can reduce, and ultimately जो उसका लाइफ है 20 साल का लाइफ है, 25 साल का लाइफ है प्लांट का, वो 25 साल का हमको जनरेशन मिल सके. एंड वो जनरेशन तभी मिल सकता है जब हम कॉलेजेस में सब जगह पे हम इस तरीके की थ्योरीज को, इस तरीके के सिस्टम्स को, इलेक्ट्रोलुमिनेशन सिस्टम है, जैसे आईवी कैरेक्टरिस्टिक सिस्टम है, ये अपना टेम्परेचर मेजरमेंट करने का सिस्टम है, इन सब सिस्टम्स को हम अपने करिकुलम में डालें, इसको स्कूल के करिकुलम में डालें, so that बच्चों को ये आइडिया लगे बेसिकली कि इस तरीके का चीज जो है that is very important, not only to the manufacture but to run the plant as well. So with this, I really thank you for patient listening, and thank you so much for giving me time and opportunity to share my ideas and understanding what we have gathered in working in company like Maharatna company like NTPC. Thank you so much.
Thank you, sir. Thank you very much, sir.
Thank you, sir. Thank you very much.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Any
बहुत
question? I am ready.
Thank you so much, sir, for your wonderful lecture. I have one doubt. You were telling about that the floating solar PV system. So, what are the causes does these floating solar system cause to the flora and fauna of the water bodies in which they are implanted or they are kept?
So this is a very, very important question,
Yeah.
as well as very means people are always asking about this question as well. The important aspect is that there are two things. One is basically definitely when you cover the complete water body, there will be no direct sunlight which is going into the kind of living animals which is in the waters. And because of that, there will be effect on them. So when we call off any type of water body which is inside the thermal plant or all those things, these are important for us also because it will reduce our cleaning requirement of water as well. But when we call off any natural kind of a lake or natural water body, where the flora and fauna is more important than anything else, there is a concept that if we capture or cover only the 30% of the water body, then there is no effect on the. There are several studies which has been conducted on such type of things. So when we cover only 30% of that water body, we will be in a position to remain the flora and fauna of that particular area in the similar manner which was earlier before that. And that is like in Bangladesh, when we are talking, they are basically very curious about that because they are not having the land. Everywhere their water bodies are there. And we suggested them this type of requirement that you can capture 30% of the water body, not the complete.
Okay, so thank you, sir. And one more. What is corrosion means?
Your voice is
These materials
breaking,
are
Dr.
free
Veena.
of corrosion or they have been coated with some. Sir, is there any chance of corrosion of these materials which are used for this floating solar PV?
So in most of the cases, when we are talking of a floater, they are always made of HDP, high density polyethylene. So as far as the floater is concerned, there is no issue of corrosion, but with the modules which are installed on the water body is prone to kind of a corrosion if there is a basically water is saline water. But in case of sweet water, that is also not an issue because most of the frame are basically aluminum. So sweet water, in case of sweet water, when we are installing, most of the cases we are installing on the sweet water, so there is not an issue. But when we go for a saline water also, there is a possibility of putting a kind of a coating on the aluminum border of the module, by which we can improve the life of the module.
Okay, sir. Thank you. Thank you so much, sir. Your lecture was wonderful, sir. Wonderful lecture.
Thank you so much. Thank you, sir.
Sir, how these solar panels are able to sustain in a high wind velocity? Because in run of
Yes,
Kutch, there is a very high wind velocity. So how you have
yes, yes, yes.
overcome this problem while
Yeah.
establishing the plants?
So what is happening is that we have a kind of a design standard where we need to see the wind velocity, prevailing wind velocity in that location. And when we do this thing, we need to have a parallel to that design of the foundation system as well. The design of the foundation system is very, very important. There are several factors like K1, K2, K3 factor, which gives us a different type of wind thrust, which is basically coming from the bottom, from the side, from the different area. And when we design that system, it ultimately leads to a kind of a mounting structure design as well as the foundation design. So these two, foundation as well as mounting structure design, comes up with the help of the prevailing wind velocity, which is basically there in the case of any zone. Like in case of Khavda also, there was another issue. The sand or the ground basically is such that it is kind of a marshy land. अब पूरा
Okay, sir.
देखेंगे दलदल पड़ा
हाँ
हुआ
दलदल
उसमें
बढ़ रहा है. Yes, yes.
तो दलदल में आपको यदि सपोज करना है तो आपको दो चीजें देखनी है, एक तो डेप्थ बढ़ानी है, विड्थ बढ़ानी है, एंड एट द सेम टाइम हाइट भी बढ़ानी है उसकी, because
Okay.
height is very important in the sense that the corrosion and everything will be ultimately water touch में कभी आ सकता है, water भर सकता है, तो उसकी height भी आपको ऊंची रखनी है. So all those things leads to almost 20% extra cost in case of Khavda, in case of run of Kutch. In the area of mounting structure only में 20% का cost बढ़ गया वहाँ पे उसका. तो ये सारी चीजें बेसिकली हमको ध्यान में रखनी पड़ती है जब when we are designing any solar system.
Okay, sir. Thank you, sir. Thank you.
Thank you, sir.
Yeah, thank you, sir, for your wonderful lecture on solar photovoltaic system. So I am
Thank you.
particularly attached with kind of research in this field, renewable energy. So my particular query is, as of now, in 2024, how much contribution of energy consumption in India coming out of this renewable energy sector, including all the solar energy, wind energy, everything? So total power consumption, yes.
So as on date, if you see that we have already reached 100 plus 75, almost 150 megawatt kind of a 150 gigawatt kind of a thing. So solar and wind capacity we have already installed, and generally the energy content in these cases is, in case of solar energy, is basically 25%, 24 to 25% average. And in the case of wind energy, it is almost 36 to 37%. So, like if you install the thermal plant, then the thermal plant case mein basically you will be able to get the energy 24 hours. But in case of solar plant, you are able to get the energy 24% or 8 hours or 5 hours kind of a thing. Wind energy also 5 to 6 hours. So even if you are installing a such type of 150 gigawatt or 160 gigawatt of power, you will be able to generate 1/4 of the energy what we are getting from the thermal plant. And that by that way, you can see that this much of billion units we are able to convert by installing 150 gigawatt of renewable energy. So both solar and wind.
Okay, sir. So my next query is, so we are directly transferring this energy to the grid, right? We are not saving it in the form of battery or any charge storage medium.
So in most of the cases, this energy is directly going into the grid, and there are several systems are being designed where basically we are talking of round the clock power. Round the clock power when we talk of is basically solar plus wind plus energy storage. Energy storage can be in the form of battery storage or can be in the form of pump storage. So when we talk of round the clock power, it means that solar और wind और storage को मिला करके आप एक ऐसा combination बनाएंगे जिसमें you are able to generate 24 hours तो नहीं, कम से कम 20-22 घंटे तो आप एनर्जी दे सकते हैं. तो इससे क्या दो एडवांटेज हो रहे हैं. इससे तो एक जो सोलर की जो इंटरमिटेंसी है जो हमेशा ग्रिड को परेशान कर रही है, दैट इज वेरी इंपॉर्टेंट टू विच वी आर एबल टू कैप्चर. बट द सेकेंड इंपॉर्टेंट एस्पेक्ट इज दैट कोई भी बेसिकली जैसे रेलवेज है या फिर इंडियन ऑयल्स है जिनको कंटिन्यूस बेसिस पर पावर चाहिए होती है, they can get the round the clock power from any developer like NTPC, and they can get the continuous power and they can replace the complete thermal power into the renewable power. तो आपका क्वेश्चन सही है कि स्टोरेज में अभी बहुत ज्यादा काम होना बाकी है, बट सोलर एंड विंड अभी जो इंस्टॉल है विदाउट स्टोरेज मोस्टली लगे हैं. बट दिस राउंड द क्लॉक पावर का जो कॉन्सेप्ट है, दिस इज गेटिंग मोमेंटम एंड बहुत जल्दी ही बेसिकली ये पिक्चर में आ रहा है.
Okay, sir. And another one, the last one. So you mentioned the third generation photovoltaic materials, particular third generation photovoltaic materials apart from those silicon. So we are still stuck in silicon-based material, right? For commercialization, highly commercialized solar cells contains, I think, only silicons. But what about the commercializations of perovskite-based material? So, because you may have better knowledge, commercialization of third generation photovoltaic material, for example, perovskite.
Yes. So there are two important aspects here actually. So we need to, because everything is getting developing kind of a thing, we need to install the plant and we need to innovate as well. Both the things should go parallelly. So that's why when we are basically installing a bigger plant and all those things and manufacturing stage, everywhere the silicon comes into picture, either in form of a PERC technology or a TOPCon technology and all those things. But there is a lot of research going on the perovskite material, which basically gives us a very, you can say, revolutionary transformation, in the sense that it will be a kind of a coating, or it can be kind of a layer which can be ultimately start generating the power. If you can put the perovskite kind of a coating somewhere, you will start getting the power and all those things. So that is a kind of a revolution. But more important part is that the kind of perovskite research is happening around the world. It is basically research is happening on the stability part of the perovskite material, because if you even make the perovskite solar cell, it will not last more than 3 to 4 years because of the an unstable material. But here we are talking of the plant of 20 years, 25 years. So definitely we need to replace all the things again and again. So that when the stability get established, or when the stability get addressed, definitely we would be in a position to bring those technology also into uh, field.
Okay, thank you, sir.
Thank you
For
so
your
much.
nice.
Thank you, sir.
Hello. May I audible, sir?
Yes, sir.
बोलिए।
Please.
हेलो।
Yes,
हाँ
yes,
सर,
you are audible.
आ रहे सर।
हाँ सर, मेरा एक क्वेरी था, जनरल है कि व्हीकल पर्सपेक्टिव से है कि हम, जैसे मंडल सर ने भी कहा है कि बैटरी स्टोरेज के लिए, पावर स्टोरेज के लिए हम काम कर सकते हैं और
जी
हो रहा है। तो
जी।
व्हीकल पर्सपेक्टिव से बात करना चाह रहा हूँ कि जनरली हर कोई व्हीकल यूज कर रहा है, तो हम कब तक एक्सपेक्ट कर सकते हैं कि हम इस जनरेशन को यूज कर सकते हैं सोलर पैनल से या व्हीकल यूज
तो
पावर के लिए?
अल्टीमेटली देखिए, व्हीकल इज सच अ बेसिकली आइटम वेयर एरिया इज वेरी इंपॉर्टेंट। ओके।
जी
अब एरिया में रिसर्च तो काफी हो रहा है अभी, जैसे पूरा सेलर सेल की एफिशिएंसी का फोकस ही एरिया एक कॉमन एरिया में कितनी एफिशिएंसी हम निकाल सकते हैं। पहले हम 200 वॉट पीक का पैनल यूज करते थे, उतने ही एरिया में 200 वॉट निकलता था। आज की डेट में 700 वॉट तक निकल रहा है, इवन 1 किलोवाट तक भी निकल सकता है कुछ समय में। एंड सेकेंड थिंग इज दैट कि हम उसको यूज कैसे करें उसको अल्टीमेटली। तो लाइक जैसे हम पेरोवस्काइट की बात कर रहे थे, हमारे पास एक फ्लेक्सिबिलिटी होना चाहिए, या लेयर काइंड ऑफ फ्लेक्सिबिलिटी होना चाहिए, जिसको कि हमने किसी भी फॉर्म में सोलर सेल को चेंज कर लें, या किसी भी फॉर्म में उसको यूज कर लें, शेप में, सॉरी नॉट फॉर्म, किसी भी शेप में उसको यूज कर लें, वो एक इम्पॉर्टेंट एस्पेक्ट है। So these two are the most important aspect. We are increasing on the efficiency. We are discussing on different technology as well. एंड एट द सेम टाइम सोलर सेल को डिफरेंट वे में यूज करना है। तीसरा इंपॉर्टेंट है बैटरी स्टोरेज, बिकॉज सोलर सेल सपोज करो आपने लगा भी दिया है, तो अकेले सोलर सेल तो चलेगा नहीं, इट हैज टू बी स्टोर्ड समवेयर। तो बैटरी स्टोरेज इन पर्टिकुलरली ईवी के केस में तो काफी इंप्रूव कर गई है। आप देखेंगे दो टाइप की बैटरी हैं, एक तो ईवी एप्लीकेशन के लिए है, और दूसरा है एक एप्लीकेशन है आपका जहाँ पे आप लार्ज स्केल ग्रिड स्टोरेज की बात करते हैं। तो ईवी एप्लीकेशन में पावर डेंसिटी, एनर्जी डेंसिटी बहुत इंपॉर्टेंट हो जाती है, जिसलिए हम लोग लिथियम आयन बैटरी की बात करते हैं। तो
जी
सोलर सेल को और एनर्जी स्टोरेज को दोनों को ही अभी जैसे कि लेके आते हैं और इस तरीके से करते हैं, तो नेक्स्ट 5-10 years में यू विल बी एबल टू सी देयर आर सेवरल थिंग्स विच आर कमिंग अप फॉर द केस ऑफ व्हीकल। अदरवाइज देखेंगे आप तो कॉलेजेस में सब जगह पे सोलर लगा करके हम ऑटो टाइप का या एक व्हीकल 3 व्हीलर टाइप का हम चलाते ही रहते हैं। बट
जी
एक
जी
एस्टेब्लिश कार के लिए, ये सब के लिए इट इज वेरी इंपॉर्टेंट।
जी। थैंक यू।
थैंक यू।
बहुत बढ़िया लेक्चर था सर, थैंक यू सो मच।
थैंक यू
और
सर, थैंक यू।
ये लेक्चर की बड़ी प्रतीक्षा थी सोलर एनर्जी के ऊपर में, और लेक्चर भी हुआ तो पूरे डिटेल के साथ में हुआ।
मैंने इतना ही कोशिश किया कि एकेडमिक और इंडस्ट्री दोनों को किसी तरीके से मिक्स कर सकूं,
बहुत अच्छा
उतना
था।
ही एफर्ट था।
नहीं नहीं, बहुत बहुत ही बढ़िया चंडू जी, बहुत ही बढ़िया। जय चंडू जी।
फॉर्मेटिव, बहुत ही अच्छा।
ये भी सर अपने जबलपुर इंजीनियरिंग कॉलेज के प्रोडक्ट हैं सर, जेईसी के
हाँ,
पढ़े हुए हैं सर।
आपसे छोटे हैं कि बड़े हैं?
ये हमसे छोटे हैं सर, जेईसी के पढ़े हुए हैं, और उसके बाद ये आईआईटी से एमटेक हैं और आईआईटी से पीएचडी हैं सर,
अच्छा।
और एनटीपीसी में इस समय जीएम है सर।
हम्म, आप लोग पूरे परिवार में सब लोग खूब लर्नेड लोग हैं।
थैंक यू सो मच।
थैंक यू सो मच सर, थैंक यू सो मच। आपने अपॉर्चुनिटी दिया बताने का, हमको तो बहुत अच्छा लगता है कि हम एनटीपीसी में क्या कर रहे हैं, क्योंकि मैं इंटरनेशनल बिजनेस से बिलोंग करता हूँ आजकल। तो मेरे को बेसिकली बिजनेस डेवलपमेंट दिया गया है, तो मेरे लिए ये सब प्लेटफॉर्म ऐसे होते हैं कि कितना ज्यादा से ज्यादा हम बता पाए अपने बिजनेस के बारे में। तो
अभी
ऑन अदर साइड दिस इज थैंक यू सो मच फॉर गिविंग दिस अपॉर्चुनिटी एज वेल।
अभी नेक्स्ट मंथ में फैकल्टी इंडक्शन प्रोग्राम में भी आपका लेक्चर रखेंगे।
थैंक यू सो मच।
थैंक यू सो मच सर, थैंक
थैंक
यू।
यू,
ओके
थैंक यू सो
ओके
मच सर, थैंक यू सो मच।
ओके,
थैंक यू सर, थैंक यू।
डिस्कनेक्ट कर रहा हूँ। थैंक यू।
Thank you, sir.